You know, in the world of AI, there's this massive arms race going on right now. But it's not what you'd think. It's not about speed or raw power. It's all about memory. The big goal? To build AIs that can remember, well, everything. Way more than we ever could. But here's the twist. That race for a perfect, infinite memory, it's just hit a really unexpected and kind of fascinating wall.
And that wall, it has a number, a huge number, 1 million tokens. I mean, just look at that. That is the absolutely staggering new memory size that some of the top AI models are claiming they can handle in a single prompt. This isn't just an upgrade. It's a number that is completely changing the game and what we thought AI could even do.
All right, so let's dive into part one, the AI memory race. And trust me, this is way more than just a contest for the biggest number. It's a full-on strategic battle between the tech giants, all trying to build models that can process insane amounts of information.
And what's just mind-blowing is how big of a leap we're talking about. So Anthropic comes out with Claude 3 Sonnet and boosts its context window to that 1 million token mark. Now, to give you some perspective on that, it's almost 8 times bigger than what its main rival, OpenAI's GPT-4o, can handle. That's not a step up, it's a giant, massive jump.
Okay, but what does 1 million tokens actually mean in the real world? Like, what can you do with that? Well, picture this. You could feed an AI an entire long novel in one go. We're talking about 750,000 words. Or, if you're a developer, imagine dropping 75,000 lines of code into a single prompt. This opens the door to these huge tasks, like analyzing a company's entire code base or summarizing massive legal archives, all at once.
Which brings us to part two, the context challenge. Because, and this is the key, it turns out that just having a bigger memory doesn't automatically make an AI any smarter. Nope. The real secret sauce is how the AI actually uses all that information. So, to really get what's going on, we need to talk about the context window. The easiest way to think about it is like the AI's short-term memory. It's basically how much information, measured in those tokens, the model can juggle in its head at any given moment to figure out what's happening in a conversation and what it should say next.
But, of course, this is where it gets complicated. The longer a conversation goes, the more these AIs start to, well, struggle. They get hit with context loss, where they completely forget something you said just 10 minutes earlier. Then there's coherence breakdown, where they'll start contradicting themselves. And my favorite, contextual drift, where the whole chat just slowly veers off into some totally random territory.
And all of this leads to a really fascinating and, frankly, a kind of counterintuitive twist in this whole story. So in part 3, we're going to explore this weird phenomenon called lost in the middle.
So we have to ask the big question, right? Is a bigger context window always better? I mean, the whole memory race we just talked about is built on the idea that, yes, of course it is. But what if it's not? The latest research is pointing to something else entirely.
And this chart, wow, it just lays out the paradox perfectly. Check this out. This research from Databricks shows that for a model like Llama 3.1, if you give it more information, its performance can actually get worse. Look at how its accuracy goes up, hits a peak, and then starts to fall off a cliff as the context gets bigger. It's almost like its brain is just getting clogged up.
And yeah, this strange effect has a name. It's called the lost in the middle problem. The analogy is perfect. It's like you read a whole book, but you can only remember the first chapter and the last chapter. The AI just can't seem to find or use the important stuff that's buried deep in the middle of a really long text.
And here is a fantastic, real-world example of this going wrong. Researchers gave Claude 3 Sonnet a big chunk of text. What happened? Well, its habit of refusing to answer questions because of copyright concerns skyrocketed. It went from less than 4% of the time to almost 50% when the context hit 64,000 tokens. Basically, it got completely overwhelmed and just fell back on a safe but totally useless answer.
Okay, so if a bigger memory isn't the silver bullet, then what is? Well, that brings us to part 4, and a really, really clever solution. It's an idea that some people are calling the USB-C for AI. And that's a perfect way to think about it.
The big idea here is something from Anthropic called the Model Context Protocol, or MCP for short. And what it is, it's an open standard. It's designed to be a universal way for AI models to plug into external tools and data instead of just trying to cram everything into their own memory. So, what MCP really does at its core is solve what developers call the M by N problem. Just think about it. Before, Every single AI app needed its own custom-built connector for every single tool it wanted to use. It was a nightmare, this tangled, messy web of integrations. MCP just throws all that out. It creates one single standard, so every app and every tool just needs to connect one time. It makes everything so much simpler.
So let's quickly break down how this whole thing actually works. Okay, so on the left, you've got the MCP host. That's your main AI app, like a chatbot. When you give it a command, it uses a client to send a message out. Now, over on the right, you have these MCP servers. You can think of these like universal power adapters for all your other software and tools, your Google Drive, your company database, you name it. And the protocol itself? That's just the standard language they all agree to speak, so the AI can grab exactly what it needs right when it needs it without its brain getting overloaded.
And it's all built on three really simple but super powerful building blocks. First, you have tools. These are just actions the AI can take, like send an email or create a calendar event. Second, resources. These are the things it can look at, like a specific file or a database entry. And last, you've got prompts, which are basically just reusable templates to help the AI talk to all these different tools in the right way. All right, let's bring it all home with our final section, Part 5, Smarter Access, Not Bigger Memory. And this, right here, this is the core of the huge shift that's happening in AI development as we speak.
So the really big takeaway from all this is simple. The future of AI, it's not going to be one single giant brain with a perfect infinite memory. No. Instead, it's going to be this flexible, interconnected ecosystem, a world where an AI can, on the fly, find and use an entire universe of specialized tools and data whenever it needs them. And that's what MCP provides. It's the universal handshake that makes this whole ecosystem possible. The process itself is just so simple and elegant. The AI discovers what tools are out there, it asks what their capabilities are, it selects the perfect one for the job, and then it executes the command. It's like a universal language for AIs to work together.
So I'll leave you with this to chew on. What kind of future are we actually building for AI? Is it a single, all-knowing superintelligence, one giant brain to rule them all? Or is the real future of intelligence something more like a huge, interconnected universe of specialists? Millions of experts, each one a master of its own little domain, all talking and collaborating through one common language. What do you think?